Hi everyone, my name is Belle, and I'm here to teach you about the periodic table and the patterns within it. This is the periodic table of elements. All of the little squares are elements. Elements are the basic building blocks of all matter. There are about 100 different elements, and they are all arranged on this table for your convenience. Each square says information about each of the elements. Let's take oxygen, for example. This is the atomic number. It tells us how many protons are in an oxygen atom. What's an atom? Atoms are the tiny little pieces that make up everything. How little are these little pieces? Let's look at a grain of salt. Pretty small, right? Well, this grain of salt has about 12 quintillion, or 12 with 17 zeros behind it. That's a lot in case you couldn't tell. Even though atoms are small, there are even smaller parts that make them up. Atoms consist of three different particles: protons, neutrons, and electrons. Protons and neutrons are in the center of an atom, also known as the nucleus. The electrons are in the space around the atom, aka the electron cloud. Protons have a positive charge, electrons have a negative charge, and a neutron has a neutral charge. If an atom has a neutral charge, what has to happen with the amount of particles? Correct! There has to be an equal number of protons to electrons. Now that that's out of the way, let's go back to our oxygen square. This is the atomic mass, or how much an atom weighs. If you take this number and round it, you get the mass number, or the amount of protons and neutrons combined. What do you think we have to do to find the number of neutrons? Right, you take the mass number and subtract the atomic number. So if we do this with an oxygen atom, we see that there is 8 neutrons, but it isn't always equal to the number of protons. Cool, right? Let's look back at our electrons again. They aren't just floating around the electron cloud randomly. There are places we can usually find them, called shells. Shells have levels, weakest to strongest. The first level can hold 2 electrons, the second can hold 8, and the third can hold 8 as well. There can be more than just 3, but we won't get into that today. All of the electrons are important, but the most important are the valence electrons. Valence electrons are the electrons on the outermost shell. Valence electrons determine an element's reactivity, or how much an atom wants to react with other elements. Let me tell you a quick story to help you understand. This is sodium, a highly reactive metal, and he is really sad because he doesn't have a full outermost shell. And this is chlorine, a highly poisonous gas, and she is sad because she doesn't have a full outermost shell. They meet and they realize that they are both so unhappy, but being together can make them happy again. They complete each other. They have formed a bond, a chemical bond in fact, like no other, and now they are both happy. They share an electron and have formed NaCl, or table salt, something we can ingest safely. Did that help? I hope so, because it took forever to animate. Okay, now that we have all the information we need, let's go back to the periodic table and look at some patterns. The columns on the periodic tables are called families, and the rows are called periods. Let's look at the periods first. They are both increasing by atomic number and atomic mass. They also change reactivity levels. It starts as highly reactive, to less reactive, to highly reactive again, to no reactivity at all. Now let's look at the families. Families all have similar characteristics, just like in real life. Why do you think they are all so similar? That's right, because of valence electrons. Each column, except these ones, have the same number of valence electrons. I feel like you guys have learned a lot today. I think you're ready for a pop quiz. I'm going to introduce 3 newly discovered elements, and we are going to try and figure out if we can guess some characteristics of them. Alright, so the first element, let's call it isabellium, has an atomic number of 150 and an atomic mass of 362. Where do you think this element would be placed? That's correct, over by the inert gases. What may be some of its characteristics? It's in the inert gas family, so it must glow with electrical current. What is its level of reactivity? That's right again, it would be non-reactive, since it has a full outermost shell. You're killing it! The next element, called fudium, has an atomic number of 119 and an atomic mass of 298. Where would this element be on the table? It would be right underneath the alkali metals, which means what for its characteristics? Good job! It would react violently with water, since that's what the other member of its family does. Why does it react so violently? That's right, it doesn't have a full outermost shell. Last one. Let's call it artium. It has an atomic number of 143 and an atomic mass of 346. Where would it be on the periodic table? Correct. It would be right in with the transition metals. What would be some of its characteristics? Right again, it wouldn't be very reactive. I didn't cover the transition metal valence electrons, so we weren't worried about that today. You guys did so awesome! I'm sorry for leaving so suddenly, but I have some other major history projects to attend to, and I couldn't think of a smooth transition. I hope you guys learned some cool stuff today, and I hope to see you around. Bye!